the bonuses. So the similar here is to use the root of 16. So this is going to be v of w to the negative first of u to the root of 16. This should be about the only thing that's bugging you. That means find the inverse of w. That's actually where I'm going to start this equation to solve. So this is y, it becomes x. Then I solve for y. I subtract the 1. I convert to a logarithm. Or actually what I'm going to do is I'm going to ln both sides. Should I ln both sides? No, I'm going to leave it base 2 because it's easier to understand in base 2. This becomes a log of base 2 whose argument is x minus 1, and that is the inverse of w. That's where it has to start off with. This might be pretty ugly. I don't know, we'll see. First thing I gotta do is find u of the root of, why did I use root of 16? What's wrong? What kind of crack am I on? Why would I say root of 16? That needs to be modified. Let's do root 24. Now root 24 is going to be 2 root 6. And that's not going to work either. Fudge. Try root 32. Root 32 is going to be 4 root 2. There's a reason I'm using that number because I think I know how this problem works out. I haven't done it, but I think I know how it works out. So that needs to be root 32. So the first thing I'm going to do is I'm going to find u of 4 root 2. You know the way this thing was set up. Yeah, we'll just leave the number bigger. 4 root 2 to the second plus 1. That's going to be 33. Now I know that this is a 33. I get to find w to the negative first of 33, which means I'm going to plug a 33 in here. It's log base 2 of 33 minus 1, which is log base 2 of 32. And that is asking what power of 2 creates a 32. And that answer is 5. Now I'm going to find v of 5, which is 2x plus 1. Twice 5 plus a 1, that's 11. A whole lot of scattered stuff there, but whatever. Consider the sequence S is the set containing 5, 12, 23, 47, 95. Which of the following recurrence relations would generate the sequence? So this is a recursive train of thought. If you can't think recursively, I don't know how you think at all. But if you can't write recursive formulas, you're not going to be a computer scientist, I can tell you that. Because that's how computers are programmed, with recursive ideas. So what you have to do is you have to look at the sequence that you're given and see if you can figure out a pattern. This one's pretty simple. Double, add 1. Twice a 5 is 10, add 1 is 11. Twice an 11 is 22, add 1, 23. This one right here that I made up is to triple and add. If I take 3 3s and add 3, I get 12, which is right there. To create this one, I take 3 12s and add 12. That's 48. What I'm doing is I'm tripling a previous term. Now, when I create this sequence, what I do is and according to the way they're defining things here, I let the first term be 3. By the way, over here, the way they're defining, your first term better be a 5, okay? The first term, a sub 0, is a 3. Now, they're using some funny notation here. They're using a sub n plus 1. That is the next term. This actually says that the next term is the current term, add 6. This one says the next term is the 3 times the current term, take away 4. All right? So I need to write a rule here. And I've got my pattern here. 3 a sub n plus 3. Oh, sorry, plus a sub n. I don't know why I'm even doing it that way. I should have come up with a better pattern here. Because that's just 4 aces of n. Pretty silly of me the way I did that. Anyways, this is my pattern. The next term is 4 times the current term. So if I want this 12, I take the current term of 3. 4 times 3 is 12. If I want that 48, the next term, I look at the current term I have, which is 12. 4 times 12 is 48. There's my pattern. All right, you guys need to figure out which one of these sequences generate that pattern up there. 21, whoever created this question, I think they were just trying to throw kids off by being really weird about it. What you actually have here are x-intercepts. You have an x-intercept at -1, 0 and 3, 0. And this is a y-intercept. It's at 0, 1/3. They didn't list the ordered pairs. So mine is the same thing. This is 0, 1/2, -3, 0, 4, 0. To write this equation, it's not that hard. You're going to use y equals a times x minus p times x minus q, which is something you have a lot of practice with. If you take away a -3, you get a +3. If you take away a 4, you get, man, I'm shot, -4. And you don't have to know the axis of symmetry or anything like that. You don't, because they gave you this point right here. Everywhere you see a y, you're a half. Everywhere you see an x, you're a 0. And then you just crank out the math, kids. You'd have a half equals a times a -12. You get kind of a funny looking fraction here, but a is -1/24. And that's it. That's all it is. 22. Consider 2 points in the Cartesian plane, which is the xy axis. Let PQ be the line segment between P and Q. Find an equation of a line that passes through the midpoint of PQ that is perpendicular to PQ. The reason I'm drawing is so that you can understand it. 2, 5 be somewhere here. -3, 12 be somewhere up here. There's your line segment, okay? Now they mentioned midpoint. I take my x's, I add them together and divide by 2. I take my y's, add them together, divide by 2. My midpoint is at -1/2 and 17/2. That's a big deal. All right. Unless it says pass to the midpoint. They also talk about perpendicularity. So I'm going to find the slope between these 2 points. Y minus y over x minus x. And there's my slope. They said perpendicular, so the perpendicular slope would be 5/7, opposite reciprocals. And last thing is they want the equation of the line that satisfies passing through that point and having that slope. So that's point slope form. Y minus y1, 17/2, equals 5/7 of x minus a -1/2 or plus a half. Then I just clean the crap up. That's all I do. y minus 17 halves is 5/7 of x plus 5/14. I'm going to have to add 17 halves to that thing, which I'm too tired to be doing right now, apparently. So 5/14 plus 17/2, 62/7. There's my equation. 5/7 of x plus 62/7. That's how you do yours. What is the value of this thing? You're not actually going to find the value. You're going to write an equation. So in my similar example, I noticed that this is a geometric sequence. The ratio, I'm just going to pick on any two random things, is -27/9, which is -3. How many terms are there? That's a good question. Because it starts with a 1 and ends at -3 to the 101st power. How many terms are there? That's what you got to ask yourself up here. How many terms are there? That's 2 to the 1st, by the way. This is 2 to the 0. That's the same deal here. That's 3 to the 0. All right? Other than the negative sign, that's 3 to the 1st. We go from 0 to 101 on this thing. There are 102 terms. There are 102 of them. Why is that important? Because the sum of n things for a geometric sequence is the first term times 1 minus r to the n over 1 minus r. So here I'm finding the sum of 102 things. It is the first term, which is a 1, which is kind of cool. Probably not even going to be mentioned. 1 minus, this is a -3. It's got to be wrapped to the 102nd power. By the way, you don't have 102 terms. You go from 0 to 100, so think about that. And where was I? Oh, we're 1 minus r, 1 minus -3. If you take a negative and you raise it to an even exponent, it's going to be positive. Yours probably stays negative. I don't know. You have to look at that. This one would clean up to look like 1 minus 3 to the 102nd over 4. And that's all you're doing is writing the equation. Suppose a quadratic model with real coefficients has a leading coefficient 1, has a root of x equals 3 plus I. What is the polynomial? Similar one here is we have a known root of 4 minus I. Its conjugate is 4 plus I. So I'm just going to write down 4 minus I times, I'm going to write down the factor. Take away 4 plus I is one factor, because when we take a 0 and enter it into parentheses, we change the sign. Take away 4 minus an I is the other factor, and I'm going to FOIL this thing out. Sorry, not FOIL. I'm going to triple distribute it. If I distribute that x to everything, I'll have x squared minus 4x minus xi. If I distribute my -4, I'll have minus 4x plus 16 minus 4i. And then I distribute the I to everything. Plus ix minus 4i. And then minus I squared. I'm trying to make sure I didn't make a mistake. Paying attention to that real coefficients. All right. What do I get here? There should be some cancellations. That's gone. That's gone. That's a plus 1. So I end up with x squared minus 8x plus 17. Looks like minus 8i. That's what bothers me. Real coefficients. That's not real. I would say that given the constraints of the problem, there's not enough information. That's what I would say. All right, suppose that the first term of something is 1 minus I, and that the next term is the next term squared take away 1. Oh, sorry, what is this? This is the previous term squared. Add back the first term. So I made up a similar one, and it shouldn't say a sub n, it should say a sub 1. So a sub 1 is 2 minus I, 2 minus I, it's supposed to be an I, and a sub n is that thing squared minus 1, find a sub 4. So a sub 1 is 2 minus I. A sub 2 would be this thing squared plus the first term. I'm just going to do that in a calculator because I'm lazy. It's 5 minus 5i. A sub 3 would be this guy squared plus the original thing. So I'm going to take that to the second. I'm going to add 2 minus I. And it is 2 minus 51i. A sub 3 would be this dude squared add back the original piece. And I got something funky. Mine got big. That's probably why they only stop at a sub 3. So negative 2595 minus 205i. There's a reason they stop at the third term. It's because it starts getting really, really big after that. So yours won't be as bad. And that, boys and girls, is the similar content for your next test.